reviews together. Okay, so let me pull up. I think it was this. D&E. Oh, okay. So are you talking about these milligrams per hour infusion, milligrams per minute infusion?
Yes.
Okay, thank you. Okay. All right. Yeah. So this is actually helpful. So first of all, milligrams per hour, milligrams per minute, micrograms per minute. These are all essentially the same thing as doing units per hour, or even if it was units per minute. It's just a matter of finding the conversion of, usually it's, so like if we're talking about milligrams per hour, you're just going to be multiplying by the milligrams per milliliter. So usually what the question would state, and I'll pull I actually just went through an example of one of these. Anyways, I'll show you how that looks, but they're basically just doing the same type conversion you're doing for units per hour as you are for milligrams per hour to milliliters per hour. I just want to see if she wrote out a practice problem for that. I don't think that she did. Again, this is the North Campus. So let me show you what I actually just went over this for 220, 230. So this isn't really going to be pertaining to you guys at Allegheny campus, but I promise I'm going to get right back into it. So this is actually, if you go to the 230 or the 230 folder for Boyce, this is where you're going to find this problem. And I just worked it out. So you're going to see that I've written it out already, but I'll kind of highlight this. So a student at Boyce put this together, and then I've been stealing it. So like here's an example of going from micrograms per minute to milliliters per hour. And so it gives you a couple things. It tells you that it's infusing at 20 micrograms per minute. Okay. So it tells you it's infusing at 20 micrograms per minute, and then it tells you that they mixed 50 milligrams and 250 milliliters dextrose 5% water. So you're going to do the same thing that you would do with the units per hour question, where you're going to take, you're going to start off with your rate, your infusion rate, which is 20 micrograms per minute. And then what you're going to do is, you don't want it in per minute though, right? You want it in per hour. So the first thing I'm going to do with this is I'm going to go ahead and convert minutes to hours, which will give me 1200 micrograms per hour. Now, once I get to that point, the 1200 micrograms per hour, now I want to convert micrograms per hour to milliliters per hour. And that's where I'm going to use this, what I have as my available. Notice it says 50 milligrams. So the first thing I want to do is I either want to convert micrograms to milligrams, or I want to convert milligrams to micrograms. So whichever way you do it is fine. So just for simplicity's sake, I'll just go ahead and convert that 1200 micrograms to milligrams. So I'm just moving my decimal point over 3. So I'm just going to rewrite that as 1.2 milligrams per hour. Okay. So this helps to take care of 2 questions in one, right? So it told you convert milligrams per hour, micrograms per minute to hour, or milligrams per minute per hour. I'm basically doing that all in this one problem, just showing you basically you're going to get it to the same part, or same point, which is being able to multiply by what you have in your IV or your infusion. Okay. So I want to get rid of milligrams and I want to convert that to milliliters. I have 250 milliliters. I have 50 milligrams. So 1.2 times 250.
I'm sorry, where did you get the 250? Is it? Oh, there it is. I'm so sorry.
Yeah,
I saw it.
yeah.
Sorry.
Okay. Yeah, I promise I did not make it up. Yeah, it was given to us. Because we wouldn't be able to solve this problem if we didn't know what that was. Oh, so I already had to answer. Was actually 6 milliliters per hour. Let me just make sure I did all that right. I have a feeling I did something wrong down here. Oh yeah, I did. Oops. Yeah, so I actually answered this question earlier today, and I actually answered it incorrectly. I even changed the key, and that was on me. So I'll have to remind them that I did that. Oops. It is 60. Okay. Sorry, that was more for the other class. But anyways, yeah, that's how you would do this. You would just, all you're going to do is you're going to do your conversions, right? So the first thing I did was I converted minutes to hours. Okay. And the reason I knew to do that is because I was looking for milliliters per hour. I already had a flow rate or an infusion rate. It was just that it was in a different, you could argue unusual, orientation or order. And so I just converted minutes to hours first, right? And I got this 1200 micrograms. Once I have this 1200 micrograms, now you can do one of two things. You can convert micrograms to milligrams, or you can convert milligrams to micrograms. As long as they're both the same unit, that's what matters most. Okay. Now you might be saying, well, why in the world, why are you doing this? Or why did you choose the way you did? I just chose it. It's completely up to you which one you do, but you need them to both be in the same unit. So whether you convert micrograms to milligrams, micrograms, as long as they're the same, now we have something to convert with. So this is the same thing as like our dilantin being 125 milligrams per 5 ml. We're basically doing the same thing. It's just now we're incorporating time as a flow rate. So you just keep the hour in there. And so then I'm just going to, if you're doing order of a half, you might have a little bit of difficulty with this, but you can do that. 1.2 over 50 times 250. You'll get the same answer. But this is a good example of what you asked me to work through is just this. And then you can even do this question up here. It's a similar process. So I'll let you try this. The key to this is on the back. And this is in the 230 Boyce campus folder, but it's applicable to the questions that Mrs. Russell gave you for North Campus. So for my reviews, really Allegheny is kind of its own animal, and then Boyce, North and South are kind of their own animal. At some point we'll all be on the same page, but we're not there yet. All right. So let me go back to the Allegheny thing, just because I want to make sure we're seeing what they need to see. And then just if you have other questions, just type it into the chat or unmute. So let me go back to this here. So for the Allegheny campus, this is, I imagine your packet still looks like this. This is the 240 review packet that you should have received. If it's different and you have an updated one, please email it to me. That way I can see what you're doing. But basically, you're going to do the same types of things. Yes, and certainly do the heparin protocol. We're going to see the same types of questions that we've seen previously, where it's just your basic unit conversions, micrograms to milligrams, teaspoons, milliliters, pounds, kilograms, etc. And then you're going to see a couple questions. So this was actually a question that was asked, I think, for 240 students that I said I would try and work out. This is an example of a microgram per kilogram per minute question that looks more difficult than it is, but it's basically the same thing, because notice it's asking you to calculate an infusion, and you're trying to say like, well, what in the world are we going to do with this? So this is actually a really good question for Allegheny campus, but also for North, Boyce, and South. This is actually worded very similar to what you would see at North, Boyce, and South. So let me do number 8, and then I will do a heparin protocol as well. So whenever you see that kilograms Like when you ever see patients' weight and then you see an order that's 5 micrograms per kilograms per weight, that's step one. Step one is taking the patient's weight and multiplying it by the order, okay? The initial thing. So 70 times 5 gives you 350 micrograms per minute, okay? So I'm just going to write out what I'm doing. So 70 kilograms times the 5 micrograms. And I write this way in what I'm showing you on purpose, okay? Because that way I know that I'm eliminating kilograms and I'm left with 350 micrograms per minute. Now, this doesn't tell me to calculate to milliliters per hour, but you should know at this point that I don't know how Mrs. Russell does it like I have no idea. So I can only show you the way that I would do it. So I don't know how she does it. So I'm sorry. I don't know. Are you are you saying like because I noticed she worked out some of the heparin protocols. So I just want hold on, I'm gonna come right back to this. On the study guide that I have, this is what was emailed to me. So I just want you to see what I have for is this. So there's no this is just converting units per hour to milliliters per hour. Okay. So I don't have anything more than this. Is this what you're talking about?
Yes.
Okay. Yeah. So
Like incorporating the weight in the problem.
okay. So and that's what are you talking about, like pounds, like converting pounds to kilograms?
Yes.
Okay. So like for this question that I'm working on now, it's already in kilograms, but I'll show you how so I don't know that you necessarily need to do it this way, but I will show you like how to incorporate the pounds in there. I'm actually going to write it in a different direction than what was written here, but I'll actually start with the pounds and then work it this way. But I can show you how you could set it up all on one line. So yeah. Okay. Thank you. Yeah, I'm actually going to do that in just a moment with the heparin protocol. So thank you for clarifying. Yeah, when somebody asks, because I don't know who Mrs. Russell is. I may have corresponded with her via email, but I don't know her her methods other than what was written there. So, and a lot of times, honestly, the way that it was written that way because it's easy to type it up. If you keep it simple like that versus like, obviously I'm writing everything. And so anyways, so you'll notice that like a lot of times when I do these problems, especially when they're more than one step or they're considered quote unquote complex, I will like kind of chop up the problem. And the reason I do that is because I like to create little stop points. If you took, chemistry and you remember you had to do these really long like dimensional analysis things, I know that most nursing students hate that. Okay. And so I don't necessarily want to force you into that. Yeah, go ahead.
So I was told that I could be wrong, correct me, nursing students, or even you, Dr. Raz, if I'm wrong, but we were told that to incorporate the pound and the kilogram in the problem because the way the pumps are set up, they could take decimals. So it's very critical to be exact on point with the weight. Because if you were to add the pound and the kilogram in the problem and then do it, like let's say you're doing it by yourself dimensional analysis, just dividing by 2.2, you're going to get a slight different answer. They said they want it exactly the same because of the pumps, the way they're set up, they could take decimal points.
Mm-hmm. So no, and that's good. And you are correct. And I will say this, and this is just my non-nurse perspective, is that makes all the difference when we're talking about pediatric dosages. But when we're talking about adult dosages, because we're rounding to the nearest 10th anyways, the answers end up becoming the same, but it's a good habit to be in. And so I agree with what you're saying, because you're doing your rounding at the very end. But I'll show you I'll show you that. I'll show you an example, and I'll even create something that has like a decimal answer, and then I'll show you what I do, like by rounding it, and that we'll come up to the same answer. But I understand what you're saying, and I will incorporate that. Thank you. Okay. All right. So for this question, we have the 350 micrograms per minute. The first thing I'm going to do is, because I know I'm looking for milliliters per hour, and the reason I know that is because I have two choices for my infusion rate: milliliters per hour or drops per minute. And I know it's not drops per minute because this doesn't say anything about a drop factor, microtubing. It doesn't say anything about a tube. It doesn't say anything like that. Okay. So that's how I know I'm looking for milliliters per hour. So step one is I'm just going to go ahead and convert this to hours. I should say step two. So I'm going to take my 350 times 60, and I'm going to get 21,000 micrograms per hour. Okay. So 21,000 micrograms per hour. Now, what I'm going to do next is, I know that my available is the 400 milligrams per 250 ml. So the way I'm looking at this, just for your own edification, I look at this as like it's a suspension. Even though it's an infusion, I'm looking at it as a suspension as far as the 400 milligrams per, like the milligrams per milliliter. That's where I'm getting that information. That's where a lot of times you can get stuck, because it's different than what you've been doing. Because normally you would say, oh, it's an oral suspension, you're just going to give them blah, blah milliliters, right? But when we're talking about infusions aren't just one-time things. It's a flow thing, right? And so that's where you have to incorporate the time, which is why we're doing all this extra math stuff. So because this tells me milligrams, but I'm in micrograms, I need to convert either milligrams to micrograms or micrograms to milligrams. And what I'm going to do is I'm just going to stay within the same thing. You could show your work with this, or if you already know that you just divide by 1,000, 21,000 micrograms is the same thing as 21 milligrams per hour. And then now I'm just going to convert all this just to get to converting milligrams to milliliters. 250, 400. So 21 times 250 divided by 400. I'm going to get 13.125. And then I would round that to 13.1 milliliter per hour. I do think the key is different on this one. Let me just double check. I don't even remember what number that was. Oh yeah, here we go. Yeah, so I think this should actually be rounded to the 13.125 milliliters, or 13.1. Because to my knowledge, you're not able to plug in all those numbers into your infusion pump. All right. So let me do something that is associated with the heparin protocol, and then let me change the patient's weight so that way it's something that is not an even number. So okay. So what I'm going to do is I'm going to do a variation of this. I'm going to do, let's say the patient in this scenario weighs 237 pounds. Okay. Now, this should be the second time that Allegheny students are seeing the heparin protocol. If you are at North, Boys South, your protocol, it just doesn't have all these like numbers and things like this. These are just showing you like what the steps of, like if you had this sitting in your chart, it's telling you everything, right? So this stuff that I'm crossing out now, that's just extra information. So you don't necessarily need to know that for the purposes of doing the math portion of this heparin protocol. So what you would see most likely at North is patient weighs 237 pounds. You're going to begin with a bolus of 80 units per kilogram, start a drip at 18 units per kilogram. It's going to give you the available is heparin 25,000 units and 250 ml half normal saline, as well as a bolus dosage strength of 1,000 units per milliliter. The first thing it's going to say is calculate the bolus dose in milliliters. Second thing it's going to say is calculate the initial infusion rate. Okay. And so it'll just be written a little bit differently. But if you're at Allegheny campus, this is what you'll see. And basically the protocol is just all these steps listed out. And then I highlighted here the important parts. And then I crossed out, obviously, the things you don't need to worry about for the math, right? Okay. All right. So let me work through this right here, incorporating the weight. Okay. So if I'm doing this, and this is just, I always start with the weight first. I know that Mrs. Russell, at least in her example, did the weight last. But if I'm going to do this, let's just consider it the long way. This is how I would do this. I would start off with the patient's weight, 237 pounds. Okay. I would then incorporate making that initial conversion of pounds to kilograms. So 1 kilogram, 2.2 pounds. Now, keeping it on one line, and I'll show you why we're doing this in just a moment. This is mainly based off of the question that was being asked. And then it tells me to begin, and my bolus is going to be 80 units per kilogram. And I'll show you an alternative way to this in just a moment, but just so you know, this is one of the reasons why I don't like doing it this way, is just because it is a lot of steps, because I don't want units. So at the end of all this, so I like to kind of cancel out units as we're going along. Okay. So kilograms is gone. So right now I'm left with units. I don't want units. I want milliliters. And if you remember, our available is for our bolus is 1,000 units per milliliter. Okay. So if you're setting this up, incorporating the patient's weight in one line, this is how this would look. Okay. Then you would just multiply across the top, divide by the bottom, and then you'd get your answer. So let me do that real quick. I'm going to take 237 times 80. Then I'm going to divide by 2.2, and then I'm going to divide by 1,000. And I'm going to get an answer of 8.61818181, just 8.61818181. Okay. So I'm actually going to, so I'll just write out what I got. 8.6181, and then that's repeating. And then we're going to round that number to 8.6 milliliters. Now, let's say I did not do the rounding. Okay. Or let's say I did the rounding at the beginning. Let's just see if we come up with the same answer. So I think it's going to be same, if not exactly the same, as far as our final answer is concerned. So if I'm doing this, the way I would set this up without making it one line, this might be something you prefer, especially if you're at Allegheny campus. Take the patient's weight. Now, mind you, for the heparin protocol, the only thing we can change is the patient's weight. 237 pounds, divide that by 2.2. Okay. And then just so you know, the way that you're stating for like Mrs. Russell, that is the right way to do it. Like the way that's written out there, that's technically the right, correct way. The only thing I'm showing you is that if you chop it up, and it will actually, you should come up with the same answer. But if you're not, and you're being told to do it the one long way, then do it the one long way. Okay. This is just another way. I would start off by getting pounds to kilograms. It would be 107.7272 repeating. So I would just do 107.7 kilograms. Then I would multiply by the 80 units per kilogram. I just want to see if we're going to get to the same answer. So 107.7 times 80 will give me 8616 units. I don't want units though. I want milliliters. And I know that I have 1,000 units per milliliter for my bolus dosage strength. And I'm going to get the same answer, that 8.6 milliliters when it's rounded. So it would be 8.616 and you'd get 8.6 milliliters. So that's what I was getting at, is whether you round it at the beginning or round it at the end, you're probably going to end up with the same answer. But if you're being told to do it like scenario, this scenario here, where the long way across, then do it that way. But you should be getting to the same answer regardless of which way you do it. But if, like I said, if you're being told and if they're checking and you're showing your work, then please, by all means, do it the long way. Now, the other reason is because of the question like this, once you know that the patient's weight in kilograms is 107.7, then you can save a couple steps, right? But I can do the same thing for B as I did with A, where I can take, I can do it the long ways, and I'll show you that, or the longer way, I'll say, or I could do it the chopped up way. But either way, you should come up with the same answer. So for this one, this is the infusion rate. So remember, it said in the protocol to start at 18 units per kilogram per hour. So if I'm doing this the way that I think that Professor Russell wants you to demonstrate it, I'm going to take the 237 pounds. I'm going to convert that to kilograms. Then I'm going to multiply it by the 18 units per kilogram per hour. And again, I'm eliminating units as I go along. So I don't want units per hour, I want milliliters per hour. This is where I'm going to use my available. The available is 25,000 units per 250 ml. So if you're sitting there going like, where am I getting all this stuff? It's written in the protocol. So if I scroll up, it tells me, here's where my bolus dosage strength is. Here's where my IV, my infusion strength is, the 25,000 units, 250 ml, half normal saline. And then this is what tells me like what to do. Bolus with 80 units, start a drip at 18 units. Then we're just answering these questions. Okay, and so I'm going to plug that all into my calculator. Again, this is just one way to solve this, but I'm going to take the 237 times 18 times 250. Then I'm going to hit equals, then divide by 2.2, and then divide by 25,000. And I'm going to get 19.39, which is 19.4 milliliters per hour. If you're doing after you've already calculated the patient's weight in kilograms, the 107.7 kilograms, then you would multiply by the 18 units per kilogram hour. Like I said, this should be about the same. That's why I'm doing this a couple different ways. And you get 1938.6 units. Again, I don't want units per hour, sorry. Again, I don't want units per hour. I want milliliters per hour. So I'm going to multiply by what we have up here, 250 ml, 25,000 units. So 1938.6 times 250 divided by 25,000 gives me 19.386, which is the same thing as rounded 19.4 milliliters per hour. So what I was getting at when I mentioned earlier, like it shouldn't matter, especially with adults, is because the kilograms is higher than if we're talking about kilograms of a child. And then we got to be careful with our rounding. But when they're an adult, the whether you round to the nearest tenth or wait until the end, you're usually coming up with the same answer. So if you're Allegheny campus, this second scenario, this is a good one for you to follow. The Allegheny campus is just following. But if they want you to show your work out as one long dimensional analysis for North, then that's how you want to follow that. And then of course you can write it out as just one line. I like to break them up. It's completely up to you. All right. Oh, so I should also add that for the Heparin protocol, like for Allegheny campus, like in the practice test, there's 4 questions, right? So we just did 2. We did a bolus and then we did the infusion rate. Okay, so that's 2 variations. Then there's 2 other questions, calculating a new bolus, calculating a new infusion rate. And that is on your test, you're either going to see the first 2 bolus infusion rate or the second 2 bolus infusion rate. The difference is with letter C here, what we're calculating for is after they've been monitored, we're retesting their clotting time. We want to know if we need to adjust it. Do we leave it alone? Do we take them off of the heparin? Do we increase the heparin? And so that's why we're looking at the APTT. Okay. Once we look at that, then we can go back to the protocol, and the protocol will tell us what to do. So like if you're at North, Boys South, it might just tell you straightforward, after they redid the APTT, or they did the APTT, it was 40 seconds. You are to rebolus with 40 units per kilogram given the patient's weight, and then increase the rate by 2 units per kilogram per hour. The initial rate was 18 units per kilograms per hour. They would give you all that information, maybe worded slightly differently than the way the protocol is put together here. Just so you know that. Anyways, so when it says calculate the number of milliliters per pair, we have to look and see, well, what are we doing here? So APTT of 43 seconds. I'm looking at step 12. It tells me APTT, the range is 36 to 44 seconds. So I know that that's what that's the range that I want to be working with. It says step 1, rebolus with 40 units per kilogram. So remember, our initial bolus was 80. So we're actually going to do half of the original. Okay. Then it tells me to increase the rate by 2 units per kilogram per hour. So these 2, I'm going to write up, I'll call it Allegheny style. And then if you want to write it out also via the long way or the longer, like single line way, go ahead and do that. And if you need me to double check it, you can just email me a picture of what you worked out, and I can tell you if you set it up correctly, if you have questions about that. And even if you're putting the pounds in a different section, I can still tell you if you're setting it up properly. Okay, so you can email me. And if you don't have my email, let me put it into the chat. All right, and I just want to make sure I did tell everyone to, okay, thank you. You did, everyone. If you came in late, I think we have the same number of people. If you came in later and you haven't done so already, please put your name and campus in the chat, but it looks like everyone already did that. All right. So, like I said, I'm going to do this Allegheny campus style. We're going to calculate a new bolus dosage strength. We're starting off with our 107.7 kilograms. Okay, because we calculate that initially, we already know what it is, and so we don't need to convert it again if we already had it. Now, if it's the first time you're seeing it, then yeah, you're gonna have to convert the patient's weight in pounds to kilograms, if that's what it tells you to do. Now, remember, I changed this question up to be 237 pounds as opposed to the 110 pounds that's listed there. So just keep that in mind. So 107.7 kilograms. Okay. And we're going to go with, instead of 80 units, it's 40 units per kilogram. Okay. So I'm going to take my 107.7 times 40. I'm going to get 4,308 units. Then I'm going to convert units to milliliters. And because we're calculating a bolus, I'm going to use the bolus dose strength. The bolus dose strength tells me 1,000 units per milliliter. And I'm going to get rounded 4.3 milliliters. What was my original? 8.6, right? Okay. Which is exactly half, which is what I was anticipating seeing. Okay. So my bolus dosage strength. Now, if you're like, oh, I got 4.308. Yes, you did. And then we round that to the nearest 10th. Okay. Now the new infusion rate. So it told me, we initially started at 18 units per kilogram per hour. Now we're going to increase it by 2 units per kilogram per hour. So I'm going to take the same patient, same weight in kilograms, but instead of calculating 18 units, I'm going to increase by 2. So 18 plus 2 is 20 units. And that's kilograms per hour. That will give me 2,154 units per hour. Remember, I don't want units per hour, right? I want milliliters per hour. So I need to convert units to milliliters. Now we're not talking about bolus anymore, right? We're talking about the infusion. The infusion's on an IV. So that's what we need to calculate for. So we do that by taking what we have available in the IV. And what do we have available? 25,000 units, 250 milliliter, half normal saline. $25,000 units, 250 milliliters, half normal saline. And then I'll do my math, and I'm going to get 21, or not 21.5, sorry, times 250 divided by 25,000. I was right. And you're going to get 21.54, but we're going to round that to just 21.5 milliliters per hour. Now, I will say this, that if you take the original, excuse me, if you take the original 19.4 and add 2, you're going to come close to the right answer. But technically, the right answer should be 21.5 milliliters, not 21.4 milliliters per hour. Okay. And the reason I'm saying that is because when I initially first saw these infusion rate questions and the heparin protocol questions, the very first thing I did was when it told me to increase it by 2 units per kilogram per hour, I was like, oh, okay, I'll just add 2 more milliliters per hour. Well, it didn't tell me to do that. It told me to account for the patient's weight. The alternative way that I saw this solved, I think was what was sent to me for North Campus as well, or was this here. So the way that Mrs. Russell accounted for the increase, so like, let's say the original was, let's see here, increase that. Okay, so it's the original was 2,300 units per hour, and then we're increasing it by 5 units per hour, and that creates a difference. Okay, so the difference is, so we started off with 2,300 units per hour, and then she just this was done just a little bit differently than what I demonstrated, in that they just took the patient's weight in kilograms times the unit per kilogram per hour difference. And so for this, it was 5 times 180, which gives you 900 units. So they just added it up. Okay, so 2,300 plus 900 gives you 3,200 total. All I'm telling you is that there's a variety of different ways to solve this, and a lot of times you may not have all the original information, which is why I mentioned or why I showed you the way I showed it to you. So yeah, everything always, I always like when us professors like to add in these things, like, see how easy that is. And it's like, everything looks easy when you've done it so many times, and everything looks daunting when you haven't done it so many times. So I promise you that if you keep practicing these things, they will get easier. They'll start to come together. You just got to keep practicing it. So, all right. Are there any other questions for 240? If so, just type them in the chat or just unmute. Let me know. Usually 240 is just worried about at least at Allegheny campus, worried again about the heparin protocol, just because you saw it, you saw it last semester, or you're seeing it again this semester. All right. All right. Well, if there's no other questions, I will be here again for 240 this evening at 6:15. And then again on Thursday at 2:30 and again at 6:15. But there's still a few minutes left if you have a question. If not, if you want to work on this a little bit more and then come back to the next session, or if you want to email me, you're welcome to email me if you have a question. And like I said, just I'll try and get back with you. If not on Thursday, definitely on Friday. So if you do have a question, don't wait until Sunday, because I may not be able to get back to you via email, but I can certainly get back to you between now and Friday. So you're welcome.